All right, now we get into enterprise database management. The, again, Internet Engineering Task Force has a database MIB. MIB stands for Management Information Base. And you can think of the MIB as the same as these AMSs. This is really the objects that we're going to be analyzing, going to be collecting and storing. And then we list some of the major areas that we want to be concerned with regards to our data management. Global user administration, so in other words, the ability to provide users the ability to access the network. We want to do so in a universal method as well, which we'll talk about a little bit later on. We need to have a heterogeneous data schema. Anytime you build a database, how many of you have built a database before? Probably not a lot of you, huh? I bet you have and you don't know it. How many of you have ever filled out a checkbook register? Which is kind of old these days too, because most of you just go online and you got it all there for you. But a basic checkbook register has the date you wrote the check number that you wrote, who you wrote it to, and how much you paid them, right? So each one of those columns is referred to as a field. The date field, the check number field, the payee field, the cost field. Well, when you get all those fields put together and you've got several entries in your checkbook there, you've got a database or a table, interchangeable at this point. Usually a database now is a collection of tables, but for now we'll use the term interchangeably. That database then is defined by all of the different columns, all of the different categories we created there: date, check number, payee, cost. So that's called the database schema. So when you build a database, you have to create fields that you're going to put data into. Once you define what all those fields are, essentially, that's your database schema. We need to have effective troubleshooting. We need to have support for some of the commonly utilized databases out there: Oracle, Informix, SQL Server, Adaptive Server, and DB2, which is IBM's high-end database system. And these are all pretty high-end database systems. You notice that Access isn't listed there, right? You notice that, trying to think, and I just forgot it, is it File Manager Pro that they used to use on the Macintosh all the time? Anyway, there's a lot of little database programs out there, even Excel for that matter. But these guys here are really high-end databases. They have a lot of sophistication to them. They have transaction processing. We talked a little bit about that the other day. Every time we want to record something, write something to the database, we actually create the task in a list first, and then we go ahead and try and record it. And if it's recorded, we can cross that off our list of tasks to do. But if it's unsuccessful, everything gets rolled back. We go back to the list again, start at the top, and start working our way down as far as step by step what we need to do to record that information. So it's a very reliable process as far as making sure information gets changed or updated, added to the database correctly.
Server as a database?
Yes, server is. Remember we talked about that the other day too. The Microsoft has a server product that is a database server product called SQL Server. Then there's also a language that is an open source language that we can use in various programs to retrieve data from a database or write data to a database, and that's called SQL, the structured query language. So there is a difference. SQL Server supports SQL, the structured query language, but they are completely different. One is a language for interacting with the database, reading, writing information, sending queries, they call it, to the database. And then the other is the actual database itself, the ability to write, record information onto the hard drive.